What do you see in this image? You might see the university library in the background. You might see my hand. You might even see what my hand is holding, a piece of glass, but I'm more interested in what you don't see. You don't see any big blue solar panels that take up thousands of kilometers just to power one city. Why not turn windows into transparent solar panels? There are plenty that already exist. An amazing material that could make this happen is the transparent and conducting gallium oxide. This versatile material can be used for a huge range of applications, including transparent electronics, UV, and gas sensors. Well, this all sounds wonderful. It can only happen if gallium oxide can be produced on a large scale for mass manufacturing. This is where me and my research comes in. First off, no, I am not trying to make solar panels. I am trying to make gallium oxide films in a way that is much faster and much cheaper than the current methods. These current techniques are very expensive and extremely slow. A 200 nanometer film, thinner than a human hair, can take 8 hours to produce, using equipment that can cost up to $1 million. If you have money to spend, you can also buy pieces of gallium oxide, but just keep in mind that a 5mm by 5mm piece will set you back around $150. So if you're a billionaire, you can buy a whole window. Therefore, these techniques are not the best for mass manufacturing. I am producing gallium oxide films using a solution-based technique that is much faster and much cheaper, called Sol Gel. I start with solution and coat a piece of glass or other transparent material to form a film, heating it up to turn it from a liquid to a solid. The challenge for me is to produce these films to a similar or of better quality than the films produced using the slow and expensive techniques. I've been able to produce films that are 100% transparent, as well as being electrically conducting. I'm currently in the process of tuning the electrical properties of my films to increase their efficiency. I am doing this by adding small amounts of metal, such as tin or silicon, to increase the number of available electrons. I am also heating up my films to change the structural properties, to make it easier for the electrons to move throughout the material. But this whole time, you've not just been looking at a piece of glass. You've been looking at a 100 nanometer film of gallium oxide that I've coated onto it. You could be looking at our future if I can complete the first step and make gallium oxide fast and affordable.